Okay, Bismillah ar-Rahman ar-Rahim. We'll do 9.4. We look at it. Actually, we don't have that much in this section. We have two main rules or two main methods to discuss the convergence and divergence of series. So we have this one, direct comparison test. We call it direct comparison test. What is it? If I have an less than or equal bn, and the bigger one converge, for sure the smaller one will converge. The bigger one, I have an less than or equal bn. If the bigger one converge, then the smaller one will converge. And this is the first one. First part. The second part, if the smaller one diverge, then the bigger one will diverge. Okay. So it means what? What we will do in this test, I'm getting a sequence. He gave me a sequence, either an or bn. I will try to find another sequence, and they know about that sequence. Is it converging or diverging? And then I will do a comparison. If I want to prove my original sequence is converging, then I'll try to get a bigger sequence converge. If I want to prove it's diverging, then I'll try to get a smaller sequence, a smaller divergent sequence. Okay. One of the things you should have in your mind that these are the common, not only that, but these are the main series which we know. 1 over n to the power p. I know that it's converging if p is greater than 1, and diverging is if b greater than, which is the p series, if b less than or equal to 1. And also I know about the geometric series, which is ar to the power n. If r, absolute value of r less than 1, then it's converge. Absolute value of r greater than or equal to 1, then it diverge. As I said, if the larger series converge, then the smaller for sure will be converging. If the smaller diverges, for sure the larger will diverge. This is the test. This is mainly the test. This is the first test. Okay. Determine the convergence or divergence of this sequence. Okay. So what is the sequence which shall come to my mind? For sure, it will be summation 1 over 3 to the power n. This what will come to my mind. And they know this is geometric. And r equal 1 over 3, since absolute value of r less than 1, then call it, yeah, let me call it, he's using what? An less than bn, let me call it bn. So that implies the sequence bn converges. Okay, so what shall I do? I need to compare it with this one, where I need this one is smaller than this one. Okay, so let me take the n term. I'll do it term by term wise. I know 1 over 2 plus 3 to the power n. Or let me do it in other words. I have 1 over 3 to the power n. Okay. This is, yeah, this is easily, I can say this one is bigger than or equal to, now what is this? 1 over 3 to the power n, which is 1 over 3 to the power n. Now, if I make the denominator bigger, then the value will be smaller. So that is greater than or equal 1 over 3 to the power n plus 2. Since I know in other words, 3 to the power n plus 2, let me do it in another way. 3 to the power n plus 2, this is greater than or equal 3 to the power n. When I do this reciprocal, I need to change the inequality since everything is positive. So you have 1 over 3 to the power n plus 2 less than or equal 3 to the power n. Or I can read it this way. I'm trying to explain it in different ways. So I know this sequence, which is my sequence, let me call it an. So I have summation. Yeah. Let me call bn 1 over 3 to the power n. So I have summation bn. And here I have an is 1 over 2 plus 3n. And I have summation an. So what I have in this expression, yeah, this is the new sequence where I know it's converging. This is my new sequence. And this is my original sequence. And I know an will be less than or equal bn. So I have everything now ready. I have an less than or equal bn. And I know bn converges. What is bn? Summation of bn converges. I mean, it's summation of bn. Summation of n converges. So the theorem implies what? The summation of an will converge. Summation of an, which is this, converges. So it's this sequence converges. Clear? I make another sequence, and that sequence I know it's converges. It's a geometric series, which is easy to finalize. It converges, and then I'll try to check that the sequence which I want to deal with is smaller than my sequence, my new sequence. Since it's smaller and the original sequence is the bigger sequence converge, then for sure the smaller sequence will converge. Let me go to this one. Yeah, by the way, I sometimes I wrote the answer somewhere here so that it's easy for me to check. Okay, to avoid mistakes. What will come to my mind? I'll do the same. So I'll take what I call an. Actually, I call it bn. I'll tell you why it is bn. An or bn. Who cares? I'll think about first 1 over square root of n. Okay. And this is, I know, 1 over n to the power half, which is p series, diverges. Since p equal half less than 1. We know p series, if b, this is a p series, 1 over n to the power half, 1 over n to the power p. If b less than equal 1, then it will diverges. Okay. If it is diverges, what I shall do, I shall bring another sequence which is smaller than my original sequence. So I need to do 1 over square root of n less than this. But this is not true. Actually, I have 1 over 2 plus root n is less than 1 over root n. I have no conclusion here. Why? Yes, I know this is diverges, but this is bigger than my original sequence. Diverges and it's bigger than my original sequence. I'm getting nothing. No conclusion. This one, I have no conclusion. What shall I do? Then I need to think about another sequence, which is smaller than my original sequence, and that sequence diverge if I want to prove it's diverging. Yeah. You need to believe me that 2 plus square root of n always less than or equal to n, not always, for n greater than or equal to 4. from 4. If you have 2, that will be 4. I mean, if you have n equal 4, you have 2 plus 2 less than or equal to 4. Correct. If you have 5, it will be 2 plus square root of 5 less than or equal 5. This is 2 point something. So for sure it's less than or equal to 5. 2 plus square root of 6 less than or equal to 6, and so on. So it's very clear. I have this for n greater than or equal to 4, 2 plus square root of n less than or equal to n. That means 1 over 2 plus root n greater than or equal to 1 over n. Yes, this is what I am looking for. And I know this series diverges. This is harmonic series. So now everything is okay. I have Bn. I'm working with An. Yeah. An. This is, no, I'm using different. Yeah. I have the smaller one. Yeah. So let me say, this is the bigger, and this is smaller. The smaller one diverges. For sure, the bigger one will diverge. And that implies, okay, the bigger one diverges. In this one, we have the other way. This one, yeah, where is it? Yeah, here, this is the bigger one. And this is the smaller one. If the bigger one converges, then the smaller one diverges. If the smaller one diverges, then the bigger one diverges. Yeah. Think about it, diverges, goes to infinity. For sure, the bigger one will go to infinity. And this, if this is going to a value, converges, yeah, the sum will be a value. So the sequence will partial sum, all of these things. So think about it like this, bigger and smaller. Okay. Yeah, I hope these two examples make it clear, especially this one. When I try to do it like what I did in this one, in the first one, there is a problem. The bigger one diverges. That will tell me nothing about the smaller one. I don't know, the smaller one maybe diverges, maybe converges. So here I have no conclusion. However, when I use this idea, I get my answer. When I use this inequality, which is you can prove either by mathematical induction or. So this is make this one smaller one, this than or equal the bigger one, and the smaller one, I know it's diverging, so the bigger one will diverge. Okay, let me do more examples. Yeah. Usually to check one idea, just you deal with the powers, with the highest power, with the highest function in both numerator and denominator, to think about which one I shall check. Okay, I know that here n over n cubed plus 1 will be less than or equal n over n cubed. Since I make the denominator bigger, for sure the value will be smaller. So this is what? This is 1 over n squared. So I know this sequence is less than this sequence. Let me make it an and bn. So I have an less than or equal bn. So this is the bigger, and this is the smaller. I know the bigger one. This is, I know it. Summation of bn will do what? Converges. Why? P series with p equal to greater than 1. So I know the bigger one converge, Let me go back. The bigger one, this is Bn, converge, then for sure the smaller one will converge. That means the summation, so my n, this is my an, which is summation, will converge. I wish it's clear. Let me do more examples. Cosine square n over 5 to the power n. Yeah, I need to check this one. If you think about it, this is will be, I know cosine square always less than or equal 1 over 5 to the power n. So this is my bigger sequence. I know this one is, so this is an less than or equal bn, and I know for bn this is converges. Y geometric, and r equal what? 1 over 5. So absolute value of r less than 1. So converge. So that means the series of the series A, I mean of this one will converge because this is the bigger one. If the bigger one converge, then the smaller one will converge. 1 over square root of n minus 1. How to do that? Now notice this is minus 1. The denominator is less, so I can write 1 over root n minus 1 greater than 1 over root n. Since the denominator is less, so it will be bigger. So this is an, or call it bn, I'm not sure. Bn, he's using bn greater than an. So this will be the smaller one. And this is bigger one. Maybe bigger and smaller, maybe better. And they know this one is what? Summation of 1 over square root of n. This is diverges. Why? P series. So it's P series with P equal what? Half, less than 1. So it's diverging. It's a divergent sequence. So that implies the new sequence, which is Bn, which is summation 1 over root n minus 1 for sure will diverge because it's bigger than this smaller one, which is divergent sequence. 1 over ln n. Sometimes you need to do or to remember some of the algebraic things. I know ln n always, let's see, be a positive number. Always they can find the k, so that ln n less than or equal n to the power c, where c is any positive number or some integer k. So you know, here I will do this. Ln n less than or equal to n. I'm talking into to infinity. Okay. So that implies 1 over ln n greater than or equal 1 over n. And they know, so now I have bn greater than or equal an. And they know that an, summation of 1 over n, this is divergent. This is harmonic, harmonic series, well known. So for sure, this is bn, or summation of 1 over ln n, that will be, it will diverge. I know 1 over n divergent, and this one is bigger than 1 over n, so for sure it will diverge. Cosine n plus 2 over root n. Okay. What shall we do? I know cosine n plus 2 over root n. This will be what? Yeah, you need to be careful now. What I have in my mind? I have in my mind the square root of n. And then it's a divergent sequence. 1 over square root of n is a divergent sequence. I know it's P series. So try to make this greater than 1 over square root of n. So it's bigger than a divergent sequence, so it will diverge. But I know cosine n, yeah, let me do it this way. Cosine is between -1 and 1. Yeah, between -1 and 1. So cosine n plus 2 is between 1 and 3. Okay. Now I'll use what? Yeah, let me do it. If I have cosine n plus 2 over square root of n, I say it's less than 3 over square root of n. This is divergent. But this one is smaller now. I'm getting nothing. No conclusion. Divergent sequence greater than another sequence, nothing. Will get no information. However, if I do the other way, cosine n plus 2 over square root of n, this is greater than 1 over square root of n. There is the difference. I know this sequence diverge. Why? It's P series with n equal half. With P. Usually with P. With the power. That will be n to the power half. Huh? Square root of n is n to the power half. So I'm concerned about this power. They call it P series. So I know this is less than 1. So it will be a divergent. And it is less than, and this sequence is greater than this. So for sure, this sequence, this series, I mean, diverge. Sorry, we don't have sequence, we have series in this case. Determine whether this series converge or diverge. What I will do? Yeah. I have 5 over 2n square plus 4n plus 3. Or let me, make it like this. 5 over 2n square plus 4n plus 3. This one is less than 5 over 2n square. Why? Because here the denominator is bigger than there. So for sure this will be less than this. And this one I can find out this series. So I have 5 over 2, it will make no difference. 5 over 2, 1 over n square. That is what? P series that will converge. And it's P series where equal to. So it's a convergent sequence. So on this one, it's smaller than this one. Huh? So this is the bigger. The bigger converge, for sure the smaller will converge. So this series will converge. I wish it's clear. Link K over K. Yeah. Link K over K. We know that, link K, for link K, huh? I have ln 1 plus ln 2 plus ln 3 plus something. This is 0. This is a value. This is more than 1. But this, if you want to compare, I can say, link K will be greater than 1 for K greater than 3. Because ln 3 is more than 1. Ln E is 1, and 3 is greater than E. Ln 4 will be greater than 1. Everything it will be greater than 1. That will be my trick. So I have len k greater than 1. It means len k over k greater than 1 over k. Yeah, he's using k or n. It's okay. These are just dummy variable. Okay. So what shall I do? Okay, that's it. This series diverge. Harmonic series. Or P series with P equal 1. Also, they call it harmonic series. And this one is bigger than this one. For K greater than 3. Yeah, that will not make a difference. I will show you why. So that means this sequence or this series diverge. Someone will say, no, we're doing this for K greater than or equal to 3. Who cares? Because this series, it will be what? It will be len 1 over 1 plus len 2 over 2 plus the series starting from 3, which might concern. This is just a number. Who cares? If this is diverge, for sure all of this will diverge. It's just a number plus infinity give you infinity. So that will diverge. Okay. So when we do the comparison, I don't care if we do not start from 1 or if not start from the starting point of the series. That is not the point. That will not make a difference. Okay. Now we'll go to the next comparison test, which I think easier. Why we need this? Look at this one. 1 over 2 to the power. I know that. Yeah, 1 over 2 to the power n minus 1. It's greater than 1 over 2 to the power n. That will not help. I got no conclusion. Why? Because this is converge. So the smaller series converge, and this is bigger. That will not help me. If the smaller series converge, the bigger series, I don't know. Maybe converge, maybe diverge. So we need what's called limit comparison test. What's the idea? Assume the terms are all positive. I check the limit, an over bn. If it is equal to a finite and positive value, then these two series, either both of them converge or both of them diverge. Okay, let me do it with these two. So I have an 1 over 2 to the power n minus 1, which I want to check. I take another sequence as another series. This is I choose this series. Now check the limit as n goes to infinity of an over bn. That will be what? The limit as n goes to infinity, 2 to the power n over 2 to the power n minus 1. What I will do, I'll divide by 2 to the power n. You know this trick. Everywhere. So I have 2 to the power n over 2 to the power n. Here I have 2 to the power n over 2 to the power n minus 1 over 2 to the power n. I'm doing it in details just to show you. 1 over 1 minus 1 over 2 to the power n. What will happen? This goes to 0 as n goes to infinity. 2 to the power infinity, infinity, 1 over infinity, that will be 0. So this limit equal 1. So it's finite and positive. This is positive and finite. That's what I need. That means what? That means these two series either both converge or both diverge. Both they will do the same thing. And they know this Bn, it's what? It's a geometric series where R equal half. So it will converge. Oops. That means what? My series, which is 1 over 2 to the power n minus 1, which I cannot do it using the regular comparison, will converge. which is clear. So you have two different tests. One test, direct comparison test. But this I need to be careful. I need to think about smaller and bigger. If the larger series converge, for sure the smaller will converge. If the smaller series diverge, for sure the larger series diverge. Other than that, it's not correct. Or I can do the limit, which will make it easier. If I do the limit, what I'm concerned about, that's the limit, the result of the limit. It should be finite and positive. It should be positive value. If that is the case, خلاص. Then these two series, either they will converge or they will diverge. I'm not concerned about smaller and bigger. Okay, this series, what will happen? Yeah, I will compare it to what? 1 over n. That will be my series, my new series. So I have an is 1 over an plus b, and I have bn is 1 over n. Then I find the limit as n goes to infinity of an over bn. That will be what? Yeah, by the way, a and b are just values. Huh? That will be limit n goes to infinity 1 over an plus b over 1 over n. I'm doing it in details. Huh? That will be n over an plus b. Same degree, so the answer is 1 over a, which is positive, since a is positive and finite. So for sure, and this series, this new series which I made, for sure it's a divergent series. Diverges. Harmonic series. So that means my series 1 over an plus b will diverge. It's a divergent series. Yeah. By the way, if you notice, if you have cosine, they need to deal with 1 over n. 1 over, cosine is between -1 and 1 somehow. If you have rational, just deal with the powers. Think about it without the powers. And this is what we will do. Yeah. If we look at this one, now this one will explain it. Now, if I have this series, what will be my new series? Or the other one, the conversion series? Just so take the power. It will be here. I don't have power. So 1, I have n squared, the highest power. So I will compare it with this one. Do the limit. And this one I know is converge. P series. Huh? Converge B series and B equal to. So it's converging. I have limit. This one over this one. That give me what? Limit n goes to infinity. Limit n goes to infinity. N square over 3n square minus 4n plus 5, which I know is 1 over 3, positive and finite. That's it. So both series converge. If I look at this one, I'll compare it with what? Powers. I have 1 over square root of n. That's it. So check now the limit. N goes to infinity. 1 over square root 3. Yeah, I need a space. 1 over square root 3n minus 2 over 1 over square root of n. What I did, I just look at the highest power, both in numerator and denominator. Numerator, 0. In the denominator, it's square root of n to the power half. Because it's n, but it's under the square root. Now do the limit. That will be what? Limit n goes to infinity, square root of n over square root 3n minus 2. I divide by square root of n everywhere. That will be limit n goes to infinity. Or I take, that will be square root of n. I take n as a common factor in the denominator. That will be what? 3 minus 2 over n. And that will be limit. You know these tricks dealing with the limit. Square root of n, square root 3 minus over n. This is cancelled. This goes to 0. So I have 1 over square root of 3, which is positive. That's it. So both series. Yeah, and this one is what? Diverges. P series with P equal half. So both diverge. Okay. Now we'll do this one. I will compare it with what? What is the highest power in the numerator? n square. And the denominator into the power 5. Just take this, n square over into the power 5, which is what? 1 over n cube. And that is what? P series converge, huh? Because P is equal to 3. So check the limit now. Limit n goes to infinity. Oops. This one, n square minus 10 over 4 into the power 5 plus n cubed times reciprocal of this. Instead of, yeah, you can do it quickly. Instead of 1 over divided by n cubed times the reciprocal of this times n cubed over 3 over 1. Very clear. This idea, when I deal with the exponent, that will make my limit finite. So I have limit n goes to infinity n to the power 5 minus 10 n cubed over 4 n to the power 5 plus n cubed. Now I have the same degree, so I have 1 over 4, which is positive. So both series converge, and this is a convergent sequence, a convergent series. I wish it's clear. This one, what will be my comparison series? Right away, what will come to my mind? Make the comparison series. Comparison series. I take the power, square root of n over n square. And that is what? I have n to the power half, 1 over n to the power 3 over 2. So it's B series converge, since B equals 3 over 2. Then I will do the limit. Limit n goes to infinity. I have this sequence over 1 over n to the power. Either you make the division or just multiply by the reciprocal of this, which is limit n goes to infinity, square root of n over n square of 1 times the reciprocal of this, n to the power 3 over 2. So what I have limit n goes to infinity, n square into the power half times into the power 3 over 2 over n square plus 1, which is 1, positive and finite. And this series converge, so my series will converge. Okay, let me do more. Determine the convergence of the divergence of this. I have n2 to the power n. I'll take it all. So we'll take my comparison series, I'll take it n2 to the power n over n cubed. The term, huh? Yeah, this one. So I have what? 2 to the power n over n square. Yeah, this series converge or diverge? This series will converge or diverge? Yeah, I need to be careful now. Okay. Yeah, this series, it will diverge by the nth term test for divergence. I'll check it now. Sometimes what will help, if you have, here I have an exponential function. Here I have just a polynomial. An exponential will go faster than the polynomial. That's what will help me, that the limit will go to infinity. So I'll just check it. Limit n goes to infinity of 2 to the power n over n square. I need to check this series. That will be what? Now, if I do the just the limit, I have 2 to the power infinity, which is infinity over infinity. Infinity square is infinity. So it means I need Lewis rule. I have infinity over infinity. Do Lewis rule, what you will get? 2 to the power n ln 2. Make it x, huh? Yeah. 2 to the power x ln 2 over 2x. Substitute, you have infinity times ln 2, which is infinity. 2 to the power infinity is infinity over infinity. I'm still having infinity over infinity. Do it again. You will get what? 2 to the power x ln 2 times ln 2, so ln 2 square, just a number. And this is 2. So what will happen now? Ln 2 square is a number, over 2 a number. 2 to the power infinity is infinity, so this limit equal to infinity. So this series, which is n square, yeah, over n square, diverge. Okay. So now I will check the limit comparison test. Limit comparison test. I'll check the limit as n goes to infinity. This is my an. An is n 2 to the power n over 4 n cube plus 1. And my bn, this is my bn. Okay, so do the limit n 2 to the power n over 4 n cube plus 1. And instead of dividing, I multiply by s reciprocal, which is n square over 2 to the power n. I'm getting what? Limit n goes to infinity. I have n cubed 2 to the power n over 4 n cubed 2 to the power n plus 2 to the power n. What I will do, divide by 2 to the power n times n cubed. Divide by 2 to the power n cubed. So that will make it easier. So I have limit n goes to infinity. I have 1 over 4 plus 2 to the power n over plus 1 over n cubed. And this is goes to 0, as in goes to infinity. So I have 1 over 4 positive. So both series, either they will diverge or converge. I know this is divergent. It means this series will diverge. Yeah. Let me do more. I think the idea is very clear. Just I'm doing examples, huh? Yeah, this one, what is my comparison test? What's the comparison series? It will be n over n cubed, huh? The series n over n cubed, which is 1 over n squared. They know this one converge, P series. So now check the limit. So this is my Bn, and my An is n over n cubed plus 1. I think you get the idea now. Limit n goes to infinity, An over Bn, and that will be limit n goes to infinity, n over n cubed plus 1 over n cubed plus 1 times the reciprocal of this, which is n squared over 1. Now I have same degree. That will be 1 positive. And this series converge. So the other series will converge. By the way, we did, I think, this example as a comparison test. But I think limit comparison test will make it easier. I think we did it n over n cubed. Yeah, we did it as a comparison test. Also, now we are doing it as a limit comparison test. Much more, yeah, more easy to deal with. This one, what will be my comparison test? My comparison series. What will be the n term of that? It will be take the highest power, square root of n, over n square. That will be 1 over n to the power 3 over 2. Okay. Which is Yeah, you can do it with the series or without. This is the end term, huh? So Bn, this is Bn. And what is An? Is this one. What I mean by conversion, this is the end term of it, huh? Bn. So I have now the limit. I know this is P series convergent, huh? Since P 3/2 greater than 1. Since P greater than 1. So do limit n goes to infinity of this. Times n to the power 3/2 over 1. I take the reciprocal of this. Yeah. Now I take, here I will do this trick for the square root. I take, yeah, take a square, take n common factor. I have 1 plus 2 over n times n to the power 3/2 over 2n square plus n plus 1. That gives me what? Limit n goes to infinity of what here? Square root of n times n to the power 3/2 times the square root 1 plus 2 over n over, yeah, I can take n square also here, common factor. We have what? 2 plus 1 over n plus 1 over n square. To half, I need half here. Do I need half? No, no need half, because I took n square as a common factor. Okay. Now what will happen? This is what? This is n square, so this cancelled. Now do the limit. I have 1 over 2 positive. So both series converge or diverge. I know this is converge, so this series will converge. So, and this series converge. Yeah, which is clear. Okay. This one. I compare it with what? My comparison to series, the n term. I have 4 to the power n over 3 to the power n, which is 4 over 3 to the power n. Now be careful, this is geometric. So this is my Bn, huh? So it's geometric. And R 4 over 3 greater than 1, so diverge. Okay. So now I find the limit. This is An. Okay, so limit n goes to infinity. 1 plus 4n, 4 to the power n, over 1 plus 3 to the power n, times the reciprocal of this, 3 to the power n, times 3 to the power n over 4 to the power n. That give me what? Yeah. I can do this. Limit n goes to infinity. Yeah, for sure I'm getting 1, but I want to write it in the right way. I have 3 to the power n. I take 4 to the power n common factor in this one. So I have 4 to the power minus n plus 1 over, here I have what? 4 to the power n. I will take 3 to the power n common factor. I have 3 to the power minus n plus 1. So these cancelled. I have 12 to the power n. And now do the infinity. I have 4 to the power minus infinity, which is 0 plus 1 over 0 plus 1, which is 1 positive. So, and I know this series diverge, so the other series will diverge too. By, if I want to rewrite it, by limit comparison test. By the way, I use the test for all of these examples. Huh? All of this example, I'm using the limit comparison test, which I think it would be easier. Yeah. Yeah, let me do more. Sine 1 over n. I'll compare it with what? Yeah, I need to think about it. Yeah. I will compare it with 1 over n. 1 over n. This is my bn. And my an, sine 1 over n. Why that will work? I know this is divergent harmonic series. Because you know that the limit as n goes to infinity of an over bn will be what? Will be sine 1 over n. The limit, don't forget the limit. Limit n goes to infinity, sine 1 over n, sine 1 over n over 1 over n. This limit, I know how to do it. I let t equal 1 over n. That will be limit as t goes to 0, sine t over t. If n goes to infinity, t will go to 0, sine t over t, and that is what? 1, positive. And this series diverge, so the other series, yeah, diverge. You can say by limit comparison test, which I forget to write usually. Okay. This one, what you will do, you will compare it with what? I'll do these two, then I'll stop. Yeah, my comparison is with what? You know what, let me do this one, then I will stop. Comparison series. What is the n term of comparison series? I have n square over n to the power 5 over 2. That will be my bn, which is n, yeah, n to the power, or I can say 1 over n to the power half, which is diverge, p series, with p equal half diverge. Now let me do the limit. Limit n goes to infinity. This is my an. An is what? 2n squared plus 3n over square root 5 plus n to the power 5. That will be what? 2n squared plus 3n over square root of 5 plus n to the power 5 times what? The reciprocal of this, which is square root of n over 1. Okay. Then what I will do, now it's just a matter of calculation. Yeah, that will give me a positive and finite number. Let me do the calculation. That will be 2 into the power 5 over 2 plus 3 into the power 3 over 2 over, okay, what I have here. Let me take into the power 5 common factor inside the square root. I have what? 5 over into the power 5 plus 1. And that gives me limit n goes to infinity. I will take into the power 5 over 2 also in the numerator. And what will be the remaining? 2 plus 3 into the power minus 1, which is 1 over n, 3 over n. Let me see. Over, here I have what? N to the power 5 over 2. Everything is positive, so I go to infinity. Square root 5 over n to the power 5 plus 1. This is cancelled. Apply the limit. You have 2 plus 0 over square root of 0 plus 1, which is 2, positive. And this series, I know it's divergent. So my original, my equation will be what? Diverge. Okay. Yeah, because we have another list, another, yeah, another case. You know, let me stop here. And then I'll continue in another video. I think the idea is very clear. Yeah, just we have this comparison test, limit comparison test, which is easy. Just you need the limit of an over bn is equal to a finite and positive value. Then either these two series converge or diverge. And we have also the comparison test, where I need to check bigger and smaller. If the larger converge, then the smaller will converge. If the smaller diverge, then the larger will diverge. And we have only one case. Since we say here it's finite and positive, and this is what I will do on the next video, and we'll do examples about it. Look at this. Now, what about if the limit is 0 of an and bn? Is that no conclusion? There is a conclusion in one case. If the series of the denominator is convergent, then the series of the numerator is convergent. What about if the series of the denominator is divergent? We don't know. Nothing. No conclusion. By the way, this exercise is 63 and 64 in the book. What about if we get infinity? Because we say it's finite. I have infinity. Then the other way, if the series of the denominator divergent, then the series of the numerator divergent. What about if the series of the denominator convergent? In this case, I don't know. No conclusion. Okay? So this is actually, I will do this since it's part of the exercises, and I will do more examples later in the next video. I will start this one. So let me stop now the recording. I think we did a good number of problems. I didn't want to have a long video. Thank you.